Hello and welcome to Mrs. Law's class. In this video, I'm going to show you how to identify a conic when it's written in general form, and then how to change it from general form to standard form so we can identify the features of the conic, and then finally we'll finish off with an application problem. Now, often you will find the equation for a conic written in general form, and it looks like this: ax squared plus bxy plus cy squared plus dx plus ey plus f equals to 0, where a, b, and c are not all equal to 0. If they are all equal to 0, we wouldn't have any of the first values, and then we would just have the last three terms, which would then end up being a line. Now, for conic sections with the axes parallel to the x-axis or y-axis, b is going to equal 0, and then we're going to get these four conics. For a circle, we know that the x squared and the y squared have to have the same coefficient, since there's only just the radius. So for a circle, a is equal to c. Now for ellipse, we know that a and c are different, so that we can have it elongated. So a does not equal c. However, we do know that a and c have the same sign. For a hyperbola, a can equal c, but if a equals c, then we'll have a rectangular hyperbola. But if a doesn't equal c, then we're not going to have a rectangular hyperbola. So the extra thing is that a and c have opposite signs, and that's what differentiates it from an ellipse. And then finally, for a parabola, we know that for a parabola that we only have an x squared or a y squared. We don't have both of them. So either a has to equal 0 or c will equal 0. But not both of them will equal 0, because if both of them equal 0, then we would have an x squared or a y squared, and we would only have a line. So let's take a look at an example. So here we have x squared plus y squared. We can see that the coefficients are the same. And then we have the rest of the terms, which actually don't really matter what they are. So as long as we know that the coefficients in front of x squared and y squared are the same, then we're going to have a circle. Okay, in the next equation, this is quite easy because you can only see that we only have an x squared and there's no y squared. So this has to be a parabola. So no y squared. So this is a parabola. All right, now it's great that we can identify the conic in general form, but it doesn't help us to graph it. So in order to graph, we need to change the general form into standard form. So what we're going to do is take a look at a couple of examples, and I'll go through the steps to show you how to do this. So the first thing is to group together all the x's and the y's in decreasing degree order, and then I recommend that you move the constant to the other side. So let's do that first in this example. Now we're going to complete the square for the x's and the y's separately, but we're going to do it at the same time. So, for example, we're going to complete the square for 2x squared plus 4x. Now recall, to complete the square, we want to factor out the coefficient in front of the x squared. So that's going to be 2. We're going to factor out the 2, and we're going to have x squared plus 2x plus something, which we don't know what that is, but let's complete the square. So the number that goes in this blank is we're going to half of 2, which is the middle coefficient. So half of 2 is 1, and then we're going to square it, so that's going to be 1. And we're going to keep going, and then we have the 6y. Now, because it's not squared, there's no completing the square for the y values, and that equals 10. However, because we added 1 inside this bracket, we also have to add something to the other side. Now, technically, we didn't really just add 1. We added 1 in the brackets, but if I redistribute this 2, I really added 2 on the left side. So therefore, we're going to add 2 on the right. All right, so let's continue. So we have 2 bracket x plus 1 all squared. So now we can factor the x squared plus 2x plus 1 to be x plus 1 all squared, and that was the whole purpose, because we want to complete the square to create a square, plus 6y equals to 12. Now this is almost looking like a parabola, because we can see that we have an x squared, but not the y. So we're going to move our squared term to the right side. So this will be negative 2, and then x plus 1 all squared plus 12. And then finally, we're going to divide everything through by 6. So when we do that, we get y equals negative 1/3. Now this whole thing here is one term. So this we're going to divide by 6. The 12 we're going to divide by 6. And same over here. So we get negative 1/3 x plus 1 all squared plus 2. So the negative 2 was joined together with the 6 to create the fraction negative 1/3. Okay, let's take a look at another example where we have x squared and y squared. So the first thing we're going to do is to regroup the terms again. So 4x squared minus 32x minus 3y squared minus 6y equals to negative 1. So again, I'm going to factor from my x's. So I'm going to factor out of 4, and I get x squared minus 8x plus a number which completes a square. So that number is going to be half of negative 8, which is negative 4. And then when I square that, I'm going to get positive 16. Okay, in the y's, we're going to factor out a negative 3. So I get y squared plus 2y plus a number. And again, we're going to half 2, which is 1, and we're going to square that to give you 1. And that equals negative 1 plus 2 numbers, since we added 2 numbers on the left side. So the 2 numbers that we added were just 16. Remember, it's going to be 4 times 16, which is 64. And then negative 3 times positive 1, which is negative 3. All right, so let's do the factoring. So we get 4 bracket x minus 4 all squared minus 3 y plus 1 all squared, and that equals to 60. And our final thing to write it in standard form is we're going to divide everything through by 60 so that my equation equals 1. So I get x minus 4 all squared over 15 minus y plus 1 all squared divided by 20, and that equals 1. And that's how you write an equation from general form and to change it into standard form. All right, the last thing I'm going to show you how to do is an application. So like the pointers from before, draw a picture, drawing the x and y axis, preferably with the vertex or the center on one of the axes or even at the origin, so you don't have to worry about h and k. And then you want to set up the equation and solve for the missing variable. Usually that missing variable is a, b, or r. And you're going to solve them by substituting the known points from the graph. So always label your picture with points that you do know. All right, so here is an example. So we have a tunnel. It's built under a river for a road, which is 12 meters wide with a 2-meter sidewalk on either side. Okay, so I've drawn part of an ellipse because it says that the top of the tunnel is semi-elliptical. All right, so now let's label some things here. We have a 12-meter wide road. So let's go from here to here, and we'll say that's 12 meters wide. But then half of that is going to be 6. And then we have a 2-meter sidewalk on either side. And this is the part here that is 2 meters. All right, the tunnel has a height of 3.6 meters at the edge of the roadway. So the edge of the roadway is where the road meets the sidewalk. So that would be right here. So that means that this point here has a height of 3.6. So we can actually label that point as 6 and 3.6. So the question says to determine the height h of the tunnel at its highest point. And that would be this point here. And we know that's going to be 0 and h. Now, knowing that it's an ellipse, let's set up our equation. So we have x squared over a squared plus y squared over b squared equals to 1. All right, so we do know a point, the 6 and the 3.6. So we're going to plug that into our equation. And that equals 1. Then the other thing that we know is that this horizontal distance here from the center to this outer edge of the ellipse is 8. Same as on the other side. So that means that 8 is my a value. So we're going to plug that in. So the only thing we're missing is actually our b value. I don't know if we're going to put a squared here. So our b value happens to actually be our height as well. So that's h squared. So let's do some simplifying. So we have 36 over 64. And 3.6 squared is 12.96 over h squared equals 1. And let's move our fraction to the other side. So we have 12.96 over h squared. And let's change the 1 to be 64 over 64. So I can subtract my fraction, and that gives me 28 over 64. All right, let's do a little bit of cross multiplying here. So we have h squared times 28. So let's move this over here. And then 12.96 times 64 is 829.44. So you either have to do long multiplication or you can use your calculator. So now we have h squared equals 29.62 once we divide both sides by 28. And then finally we're going to square root. So the height of this tunnel is 5.443. Let's round to 3 decimals. So we can say that the height of the tunnel at its highest point is 5.443, and don't forget a unit, and that will be meters. And that's how you do a word problem.